Hi guys, and welcome back to Physical Sciences for Year 10 in the Australian curriculum. In this video we're going to be looking at nuclear energy. Now previously we talked about chemical energy and the idea that chemical potential energy was the energy that happened between atoms. It was when we took an atom and we broke it apart. Now when we look at nuclear energy is the energy which is stored in the nucleus of the atom. Now if you look at the diagram that we've got on the right hand side, you've got an atom there with the yellow balls representing the electrons spinning around the outside, and then in the center is that dense set of particles of protons and neutrons which make up the nucleus. Now what happens is with nuclear energy we split the inside of that nucleus, so it's not between atoms, it's the inside of the atom which is split. Now more often than not these particles are held together incredibly tightly. Now the force holding them tightly together, once they split, that energy is then released. And it was Einstein who came up with his famous equation of relativity, E equals mc squared, which basically stated that mass is converted into energy and vice versa. Now what happens when we split the atom, the masses change, and as the masses change, the difference between the change in masses is the release of energy. Now you do that on one atom, it's not a huge amount of energy, but do that over billions of atoms in a certain amount of substance or nuclear material, you've got a huge amount of energy which is released. Now that energy is often released in the form of heat, and that heat can then be utilized in a variety of different ways. In most cases what happens is it's converted into the heat, it converts water into steam, and then steam can be channeled to drive a turbine, which can drive electricity. But we'll find that nuclear energy is used at a variety of different places. For example, the American Navy used nuclear reactors in their warships. We also have nuclear submarines. That means they're generated by a nuclear reactor, and it's the nuclear reactor which generates the energy. Now what this means is, because the nuclear fuel can last a long time, these ships and submarines don't have to put into port, which means they don't need fuel, and as a result they can stay at sea for a lot longer. We've also seen that just like in Japan, we've got nuclear power stations. Those nuclear power stations can basically generate enough energy from the breakdown of nuclear radioactive material, can be converted into electrical energy, which can then be utilized. The real problem with nuclear energy is what do you do with the radioactive substance after it's gone past its usable use by date? When you've used up as much of the nuclear energy as you possibly can, it's still radioactive, and that's the major problem that's sort of facing man at the moment when we look at alternative energy sources. So just to reiterate, nuclear energy is the type of energy which you get from the inside of an atom when the nucleus splits. Now all of the energy that we have on this in the universe or in our solar system is actually as a result of nuclear energy from the sun. What you've got is nuclear energy is happening inside the sun, it's being split open, huge amounts of energy are being generated. The Earth's core, the inner core, is basically set up, we know it's incredibly hot, and that heat is generated again by nuclear material. Let's face it, from the Big Bang Theory, or scientists believe that the Big Bang was an explosion of a star. Well, a star similar to our sun has nuclear reactions going on, so it would stand to reason that the inside or the core of our planet is made up from nuclear reactions. So, hope that's explained nuclear potential energy to you. Join me again when we look at another form of energy. Thanks for watching.